Hi everyone, and welcome back to the Intro to Quest video series. In this final section, I'll be talking about how to submit your job on Quest. All right, so first, I just wanted to talk about the fact that there are different types of jobs that you can submit on Quest. So the two kind of main categories are batch jobs and interactive jobs. And the batch job is where you submit your job as a pre-written bash script. And the benefit of taking this approach is that you can submit your job and close your terminal, close your computer, and forget about it. And once your job is done, you'll receive a notification that you can go back to. So this is easy. And on the other hand, the interactive job is where you run an interactive session directly on the compute nodes. And the benefit of taking this approach is that it's really handy for exploratory work or troubleshooting, etc. But the downside of this is that once you close your terminal or close your computer, then your job will be terminated. So in this section, I will first be going over how to set up your job using the batch job example. But most of what I say in the batch job section also applies to the interactive job submission, and I'll kind of note how to transfer those things in a later slide. All right, so here on this slide, on the left-hand part of the slide, I'm showing you what your job script might look like. And I know this is a lot, you don't have to worry about the details right now, but basically your script will look something like this. And as I wrote down on the right-hand part of the slide here, in order for you to submit this batch job on Quest, you will be entering sbatch followed by the script file name. So this will be the submission command. So in the following section, I'll be talking about how you can kind of set up the contents of this submission script. So first, let's break down the different components of this script. So this top section where you see a bunch of hashtags, this is where you tell Slurm what you want in terms of the amount and type of computational resources. These commands are called headers or Slurm directives. And I think this is where it gets the most confusing. So I'll be going over each element in the following slides. The second section here is where I'm loading any modules that I might need. And I talked a little bit about modules in a previous section of this video series, so please refer to that if you're not familiar. And finally, in this last part, this is where I'm running my Python script. So in the following section, I'll be talking mostly about these Slurm directives that you see at the top. But before we get into each one of them, I just wanted to briefly note that there are short forms and long forms to these Slurm directives. So in the left panel, I'm showing you the long form. So for example, here we see -- account equals something something. But on the right-hand side, we see hashtag sbatch followed by hyphen uppercase A space, and then the allocation. So in Slurm's perspective, these are completely equal. It doesn't care which one we use. You're free to use whichever one makes more sense to you, but for the purpose of this tutorial, I'll be sticking to the long form just for clarity purposes. All right, so let's get into the directives. This first one here is called account, and this is where you indicate the allocation that you want to use in this job submission. So as we see here, it's -- account equal followed by your allocation. So how do you know which allocations that you can use in this section? You can try running the command groups followed by your own net ID. And this command will print all the different allocations that you're a part of. So in this example here, in the purple box, we see the net ID and a general access allocation P12345, a buy-in allocation B10000, and then perhaps some other allocations. So you can put any of these allocations in this account section, but you do want to be careful because not all allocations have compute resources associated with it. So if you have a storage only allocation, then you cannot use that allocation in this account directive. So this is something that is worth checking if you're getting errors here. All right, so the next directive is the partition directive. This is where you kind of indicate the category of resources that you are going to need for this job. So how do you know which partition to select? If your allocation starts with a P or an E, so if your allocation is a general access allocation or a classroom allocation, then you can use one of the following. You can use short, normal, or long, depending on how long you expect your job is going to be. You can specify Gen GPU if you want access to GPU resources, or you can specify Gen High Mem if you want access to high memory nodes. The partition short can accommodate up to jobs that run up to 4 hours. Normal is up to 48 hours, and long is up to 7 days. So this is what I mean by you can specify the category of resources that you're going to need. And things are a little bit different if your allocation is a buy-in allocation. So here, as I wrote on the slide, if your allocation starts with a B, generally you can simply put the allocation name in this partition directive. So you can do -- account B1234 -- partition B1234. However, there are some exceptions to this rule. So for example, B1042 is the genomic compute cluster, and the partition, you need to indicate something else. So this, if you're getting errors, is something that you can check with your allocation manager. Next up is the nodes directive. So this is where you indicate the number of nodes that you want to request for your job. And as I might have mentioned in a previous video of this series, here nodes means the same thing as computers. So how many computers do you want to request for your job? I want to emphasize here that unless your program is explicitly states that it can run across multiple nodes, you should always default to nodes equals 1. And a good rule of thumb is that if your job doesn't rely on software like OpenMPI, MPitch, or Intel MPI, then most likely you should always say nodes equals 1. The next one is n tasks per node. And this is where you tell Slurm how many cores or how many CPUs you want for your job. This is kind of a similar rule of thumb as the previous slide, where unless your program is specifically designed to run across multiple cores, then it's a good idea to always select 1. But there are many, many more programs that can accommodate multi-core parallelization as opposed to multi-node. And some examples of softwares that can support multi-core parallelization include something like Python scikit-learn or RSD seek2 and things like that. I do want to note here, though, that even for these programs, you still most likely need to explicitly tell the software how many nodes you want it to use. So this is something to keep in mind, that oftentimes these packages don't automatically detect the number of cores correctly, especially in an HPC setting. A quick side note here in relation to the n tasks per node is that Slurm actually has a very useful built-in environment variable that you can use. The variable name is slurm_n tasks. And this is automatically set to the number of cores that are allocated to this specific job. So let's say for the Python script that I'm running at the bottom of the script here, if I wanted to kind of plug in the number of cores that are allocated for this job, I can call that number by using this environment variable. So this is just kind of a quick tip in case you want to have that built-in function. All right, so next up is time. This is pretty straightforward, but here, this is where you indicate the amount of time that you expect your job to take, kind of the upper limit of it. And I understand it's kind of difficult to estimate how much time your job might take, especially if you have not run that job before. But I suggest that you can start with the conservative estimate. So if you think that your job might take something like 30 minutes, you can request an hour or even 2 hours. And then once that job completes and you have a better idea of how much time your job might take, you can go back to your script and adjust the time requested accordingly. Next up is the memory that is requested. So you can indicate this by --mem or --m per CPU. And this is kind of similar to the previous slide in that I understand it's really difficult to estimate how much memory a job might take before you've actually run it. So I suggest also that for this one, you can start with a conservative estimate and then go back to your script and adjust the amount of memory requested after you have done like a test run or something like that. I do want to note here that as I wrote down on the slide, this directive, whatever you specify here, affects your job's pending time by quite a lot. So if you request a lot of memory, your job might be kind of in the queue pending for quite a long time. All right, so you might be wondering, okay, so I submitted a job, I want to adjust my requested memory or amount of time according to what I ended up using. How do you check the levels of resource utilization for past jobs? I want to introduce two useful commands for this. The first one is check job, and the second one is SF or SEF. So check job is the one where it prints a long, detailed summary of that given job, and SF is kind of a short form of it, so it only prints the efficiency summary of a given job. And the way that you use this command is something like this, where you type in SF followed by your job ID that you want to look into. And Quest will print this efficiency summary, including the job ID, the net ID, the state of the job, the number of cores, CPU efficiency, and memory efficiency. So I want to take 1 second here to see if you can spot any problematic trends that might need to be adjusted for a future run. So you might notice that the user requested 4 cores for this job, but the CPU efficiency is actually roughly 25%. So this is very likely that even though we requested 4 cores, our program only ran on a single core. So this is something to note, and you can either go back and change your batch script to request only 1 core, or if you expect this job to run across 4 cores, then you might want to go back to whatever software you're running and see if you are able to specify the number of cores in a more effective manner. Another thing that you might notice is the memory efficiency. So here the user requested 10 gigabytes of memory, but the job only ended up using 366 megabytes of memory. So this is probably where you would go back and change the memory requested to something like 1 gigabyte. All right, so let's go back to our example script. The next up is the job name slurm directive. So this is where you can set kind of a descriptive name for your job for mainly for ease of identification. So Slurm does not really care what you name your job. It doesn't actually even require you to name your job, but I found for myself that setting the job name to something short and descriptive can be useful later when you are kind of searching through the past jobs that you submitted and trying to identify which one was which. The next one is the output directive. Now, just to clarify, this is where the standard output is written. What this means is that if your program has any print statements, this is where it will be written. On the other hand, if your program is saving any data files or plots, those will be directed somewhere else, which can often be specified within the software call. Another thing to keep in mind is that slurm expects you to specify a full path with the file name in this directive, not just the output directory. So here you would want something like --output equal /projects /allocation ID /outlog.txt or something like that. Another thing to keep in mind is that it's always encouraged that you direct your output to the projects directory. This is because some programs have quite a lot of print statements, and large standard output files, when directed to your home directory, can overflow your home directory quota. When your home directory is way too full, it can result in your jobs prematurely failing, or you're not being able to log into Quest and things like that. So it's always a good idea to direct your outputs to projects. All right, so finally here, these last two lines are where you can set your email notification preferences. So the first one, --mail type, is where you can tell Slurm which notifications you want to receive. So you can do mail type all if you want all possible notifications, or you can do a combination of start, end, and fail separated by comma to kind of tailor the notifications to your needs. I personally like doing end and fail to receive notifications when my job either finishes successfully or fails. And then the last one, mail user, is where you can specify your own email address that you want to receive notifications to. All right, so that was kind of a walkthrough of how to set up your bash script. And in the next couple of slides, I want to highlight how all this can be transferred to submit a interactive job. And it's most things can be translated. But the interactive job, the way that you submit it, there are a couple of commands, but the first one that I wanted to introduce is srun. So you will be submitting your interactive job by the command srun, followed by all the directives that we talked about in the batch job submission script. So we have account here, we have the time, we have number of CPUs, the partition, memory, etc. Once you hit enter here, Quest will print a bunch of outputs on your terminal screen, and then eventually you'll be directed to a prompt. Now, the way that you know that you have been brought to a compute node is by looking at this prompt. In this first prompt, you can see that it says Q user followed by two numbers. Q user is the names of the login nodes. So this is how you know that you are on a login node. On the other hand, in this second prompt that you see, it says Q node followed by some digits. So this is how you know that you are on a compute node. Compute nodes are named Q node followed by something. So once you're brought to this prompt, you can run your interactive session. You can use up all the cores and memory resources that you requested in the submission. The other method of submitting your interactive job is by the command salloc. So this stands for allocation. And it's very, very similar to srun, but one difference is that it requires you to kind of explicitly jump to the compute node that you have been assigned to. So what I mean by that is the following. So first you submit your interactive job by the salloc command, followed by the allocation, partition, etc. Once you hit enter, Quest is going to print some output lines here, and then the final one is going to say nodes XYZ are ready for job. So this is where you know which compute node your job has been assigned to. But your prompt will still be queue user because you're still on a login node. So this is where you want to run your SSH command to jump to the compute node that you've been assigned to. Once you run this, your prompt will be queue node 6702. So you will be directed to the compute node where you can run your interactive session. So as you can see, most of what we talked about in the batch job in terms of the resource requests can transfer to interactive job, but it's just that the command, the way that you submit the job is a little bit different. All right, so before we go into demonstrations for this section, I just wanted to introduce 4 kind of useful commands that might help you in managing and troubleshooting your workflow. So the first one is a command where you can see all your pending and running jobs. And the command is sq. So the way that you use this command is by running sq followed by -u followed by your own NetID. This prints a summary of all your running or pending jobs, including the job ID, the partition, your job name, the status of the job, and the amount of time it's been running. So this is really useful if you're trying to kind of monitor ongoing jobs or pending jobs. The next command is can be used kind of similarly, but this is where you can see all jobs, including ones that are completed or failed or timed out or things like that, not only ones that are pending or running. And the command is saccount or SACCT. The way that you can use this command is by running saccount followed by -x. And then you can specify your own NetID if you want to select a given user. And then you can do something like select a time window by specifying the start time and end time, as I'm doing in this example here. This prints a summary of the list of jobs, kind of similar to what you saw before, including the job ID, the job name, partition, the state of the jobs, and things like that. So this is where you might see that selecting a job name that is short and descriptive can come in handy. So you might see all these jobs are named test job, and it can be difficult to, for example, remember how these were different. So this is where it might come in handy if you're looking at your past jobs and thinking about, oh, what was the job ID of this program that I submitted, and if you have a descriptive job name, it makes it a little easier to identify those jobs. The third command that I wanted to introduce is actually also the same account or the same command, saccount. But this time, this allows you to see the content of the batch submission script. So the command goes like this. It's saccount followed by -j, followed by a given job ID, followed by -B. This specific command will print the contents of the batch script for this given job ID. This can come in really handy if you are kind of continuously updating your batch script. And if you wanted to see, oh, how much resources or what kind of resources did I request for this past submission, or what was the version of the module that I loaded or something like that, this command can come in quite handy. All right, so finally, the last one that I wanted to talk about is the command that allows you to estimate the amount of pending time for a given submission. The command is sbatch, which is the same command as what you would use to actually submit the job, but followed by --test, followed by the submission script name, file name. And this will print this kind of slurm's best guess on when this job will start. So if you're trying to ask questions like, how much time will this job be pending if I requested 100 gigabytes of memory versus 200 gigabytes of memory, you can use this command to kind of get a rough estimate. Although I do want to note that this is Slurm's best guess at that moment, so it's not always accurate, but sometimes it's nice to see kind of these estimates on how long your wait time might be. All right, so before we go into demonstrations, I just want to briefly note that on our GitHub, we actually have quite a few example job scripts that you can use kind of as a template to build your own workflow on top of. So you can go to our GitHub at NUIT-RCS, and then in the repository example jobs, we have a bunch of scripts that you can freely use for your own purposes. All right, so let's go into demonstrations. I'm currently on Quest and in a directory called Intro to Quest that I created previously for the purpose of this video. Let's try listing the contents of our current directory. We can see that there are a couple of directories named codes and data, but we also have this script here called example_script.sh. So I want to show you the contents of this script, and I'm going to use a command called vim. Now, we actually have a separate video on how to view and edit files on Quest. So we'll link that video in our description here, but for the purpose of this video section, I'll be using vim. Hit enter. And here is the content of the example script. So we have the account or allocation specified, we have the partition, we set our time to 1 minute, requesting 1 node and 1 CPU, 1 gigabyte of memory, which is probably going to be way too much. And as you can see here in the output directive, I specified the full path, including the file name, example_script.out. I've set the email notification preferences so that I'll receive an email when the job either ends or fails. And I've listed my own email here. And this script, what it does is it simply prints hello world into standard output. So it should finish pretty quick. So in order to exit out of vim, I'll type :Q. All right, so now let's test out one of the commands that I mentioned in my slides, actually, that helps us get an estimate of how much pending time this job might have. So if you recall, the command was sbatch --test and the script name. Hit enter. And we get a nice estimate of how much time it might be, or what time this script might start if I submitted it right now. So let's try submitting it for real this time. Sbatch example script.sh, hit enter. So Slurm immediately gives me a job ID once it's submitted. Let's try looking at the submitted job with SQ_U, and you put your own net ID here. Demo, enter. So we can see that the job that we just submitted is currently pending, in a pending state. So I'll wait for a couple more moments until it finishes. All right, so I got an email notification saying that my job finished. So now if we run SQ again, we will no longer see this job in our queue. But if we wanted to go back and check the status of this job, we can do this by running saccount, followed by -x, -j, and specify the job ID here. Hit enter. So we can see here the job name, partition, account, and the state of the job says it's completed. So once we list the contents of our current directory, we now see that we have this example_script.out file. So let's try looking at the contents of this file. We can do this by the cat command. So the cat command prints the contents of a text file onto your terminal. So when we hit enter, we'll see that print statement that we had in our script, hello world. All right, the next thing that I want to show you is the command to check the resource utilization of a job. So here we get our job ID, and the command is SF, stands for efficiency. So we run SF, and we see this resource utilization summary printed. We could see that we barely used any computing resources, and we used only 1 megabyte of memory out of the 1 gigabyte that we requested. So this is where you can go back to your script, and if there's any discrepancy between what you requested and what you ended up using, you can modify your script for future reference. So that is the end of this fifth and final section of the Intro to Quest video series. I hope this gave you a good idea of kind of the introduction to how to submit your job on Quest, how to set up your workflow, how to think about how much resources to request and things like that. And at Research Computing, we're always happy to help you troubleshoot things or help you transfer your workflow to Quest. So please feel free to reach out to us at quest-help@northwestern.edu.